Hello, everyone. May I have your attention? We are about to start panel 1. At this moment, I would like to introduce the chair of this session. You already know her very well and her work, but I would like to reintroduce you to Silvia Mejia, who comes from El Colegio de la Frontera Norte. Silvia, the floor is yours.
Thank you very much. So we're going to start the session on this is Eileen. We're going to start the session on cognitive resilience and aging. And I'm very pleased to present the four participants who are here. Each of them have been chosen specifically to talk to us about one of the things that are happening in this area of cognitive aging. And the first one is Eileen Graham. Eileen is associate professor for Northwestern University. Then we will have Miguel Arce Renteria. He's from Mexico. He's from Tijuana, but he now works at Columbia University Medical Center. He's an associate research scientist and clinical neuropsychologist. We have Bill Vega, who is known by all of us, and Bill is a distinguished professor of community health at Florida International University. And we're gonna finish with Melissa Lamar, who is a full professor from Rush Alzheimer's Disease Center. She's gonna be connected through line. And we have a great discussant, who is Andrea Solden. Is that the way I have to pronounce? Okay, Anya is an associate professor, and she's in Johns Hopkins University School of Medicine. So welcome to the session, and Eileen, you're the first. I'll let you know.
5 minutes left. Okay. Oh dear, got the papers. Well, first of all, I'd like to thank you all for having me here today. It really is an honor to be invited to speak with you all today. Before I get started, I'd like to thank all of my close collaborators. I know acknowledgements kind of gets stuffed off to the end, but I just want to thank everyone that I work with, all of my close collaborators, in particular, Graciela Muniz-Terrera, who by total surprise is here today. I haven't seen her in like 4 years, so I'm really excited to catch up with her later, as well as my funders at NIA, without whom this work would not be possible. So the bulk of my substantive work fits into this broad theoretical model. Broadly speaking, I'm interested in the interplay between psychosocial factors in early adulthood, health behaviors and lifestyle factors in middle adulthood, and then various health outcomes in older adulthood. So today my focus is going to be on cognitive functions, specifically personality traits as predictors of various cognitive outcomes. So just in brief, the Big Five personality trait taxonomy is one commonly used tool for capturing an individual's typical patterns of thinking, feeling, and behaving. Personality traits have previously been linked to a number of health behaviors and health outcomes, sometimes with conflicting results in the literature or prevalence of single study papers. So I've sought in my career to systematically test these pathways using the coordinated analysis framework. So we do a lot of large scale conceptual replication work, doing conceptual harmonization of the various measurement tools across the studies that are designed to test the same constructs. So we use many data sets, identical models, and then the tools of meta-analysis to synthesize these results to give hopefully a more robust body of work in the end. So just to give you an overview, oh, that is really blurry, I'm sorry. So I'll just tell you what it is. So we, excuse me, my work has shown that personality traits in early and middle adulthood are related to consequential health outcomes in later life. So this particular paper was a conceptual replication of 15 studies. We found that individuals who are higher in conscientiousness are found to be consistently less likely to be smokers. They're less likely to be heavy drinkers, and they're more likely to engage in regular to vigorous physical activity. All of these things, of course, have strong potential to lead to better health in older age. Personality is also related to several health outcomes, including general cognition, which I'll get to in more detail later. The findings from this paper suggest that neuroticism is associated with poor self-reported health, particularly in midlife. Conscientiousness is associated with less general disease level, particularly in older adulthood, and being high in openness is associated with better cognitive function, particularly in younger and older adulthood. So this particular paper was a conceptual replication as well. These findings were consistent across 3 independent data sets, although what I'm showing you here is just from the health and retirement study. So then to connect this to more downstream, the ultimate health outcome, mortality, we've also linked personality to how long an individual is likely to survive. In the interest of space, I'm only showing you a forest plot from one trait. So this is just for conscientiousness. You'll see conscientiousness is kind of a theme as we go. We found that in several independent data sets, upwards of 15, I believe, that conscientiousness and openness were protective against mortality. So people who were higher on these traits tended to live longer, and that neuroticism was a risk factor, meaning that people higher in neuroticism tended to die sooner. So all told, this body of work has suggested to us that personality traits, in particular conscientiousness, openness, and neuroticism, are associated with a breadth of health factors, health behaviors, and health outcomes, including self-rated health, disease, and mortality. And these findings have been robust across many data sets using identical models. And I'd like to preface this by saying that a lot of the work that we do has been using what, I don't know if you guys are familiar with the term weird samples. They tend to be white, educated, developed countries. So some of the work that we're doing, I'll get to this at the end, is looking to diversify the samples of people that we're looking at so that our findings are more robust and generalizable to the true world population. So then what about cognitive function? So that's really why we're here today. So the following findings that I'm going to talk about are from 2 of my most recent papers, and then another that are some preliminary findings from an article that is hopefully soon to be under review. And these 2 papers here were funded by an NIA administrative supplement that we received a couple years ago to bring our work on personality and well-being trajectories in older adulthood into the ADRD research world, which is really where my heart lies as far as research goes. So just a couple quick definitions, just so we're all on the same page before I get into our findings. We've looked at cognitive function and change. So when I refer to these things, we're talking about cognitive ability at a single time point, or on average over the course of a study. So if we're looking at multiple measurement occasions, we're looking at the intercepts. And then also we look at the rate of decline, cognitive change. So this will be referring to the calculation of slope over many measurement occasions. When we refer to risk of dementia, this is the odds of being identified as having dementia at some point in a given study. And this is in reference to the clinical syndrome only. So mostly as diagnosed by a neuropsychological evaluation within the context of data collection, not referring to any underlying pathology. We do have a couple studies that used self-reported dementia, which I realize has like major limitations to it, but we found really consistent results, whether it was dementia identified by neuropsych eval or by self-report, which we were surprised by, but that was kind of cool. So next, when I refer to cognitive resilience, this is a very specific term that we use, and it is only when discussing the relative discord between an individual's cognitive function as observed while they were alive, while they were collecting these cognitive batteries, versus their neuropathologic burden. Any study that I described that uses this term has analyzed data from studies that acquired autopsy data from their deceased participants. And interestingly, all of those data sets were collected right next door at Rush. We've collaborated extensively with the Rush ADRC, with David Bennett and Brian James and all those guys, using their autopsy data from the Ross and MAP and Mars study. So then lastly, compression of morbidity is a framework that we use to contextualize. It describes an overarching goal in the field that is to optimize the health span of an individual or population. So we all recognize that we can't fully prevent the accumulation of neuropathology. We've identified as many as 80% of people after they die have this accumulation to some extent, but not everybody observes clinical dementia. We can't fully stave off cognitive decline or even dementia completely, but there's hope that we can identify these psychological factors that are associated with maintaining relatively high functioning for as long as possible and compressing that state of poor function into as short a window as possible, so that the aging population can maintain a higher quality of life for as much of their older years as possible. So there's a body of literature that's already linked personality traits to various cognitive aging outcomes. There's a number of single study papers, a bunch of meta-analyses. The most robustly linked traits are lower openness, lower conscientiousness, and high neuroticism have been linked to worse overall function, steeper decline, and higher risk of dementia. So of course, we wanted to replicate all this work and extend it further to questions of compression of morbidity and cognitive resilience. So when thinking about why personality might be associated with cognitive health, this figure is helpful. This is just a theoretical model. It's not based on any real data. But personality may be influencing cognition in one of two ways. First, using the theory of preserved differentiation, having certain traits is linked with higher cognitive levels overall, and this advantage is maintained throughout old age. So even though the same amount of decline is being observed roughly for everyone, so this is more of like an intercept model. Then in the model of differential preservation, this suggests that individuals with certain traits are able to differentially preserve their cognition over the course of their lives, meaning they experience less cognitive decline than others. So in other words, the left hand is predicting, personality would be predicting the intercepts, while in the second, personality would be predicting the slopes in addition. So this project here, the first paper I wanted to show you, explored the associations between personality traits and cognitive decline, both before and after a dementia diagnosis. The goal here was to see if we could find evidence for the compression of morbidity, and indeed we did. So this paper was a coordinated analysis of 4 data sets. We needed a lot of cognitive data in order to do it. And then it was also a registered report. So if you're not familiar with the registered report format, it's kind of cool. You submit all of your materials, it's like the protocol of what you're going to do, that gets peer reviewed and accepted. So then they publish your results regardless of what you actually find. So it allows null findings to more easily enter the record, helps mitigate file door effects. So we found that personality traits were linked with overall cognitive function. So this was evidence for preserved differentiation, but not with overall decline, not differential preservation. However, once we partitioned those slopes for pre and post-dementia diagnosis, we found evidence for associations between openness and post-dementia slope, suggesting that people with higher openness have better overall cognitive function, but steeper declines if and when they develop dementia. So we consider this potential evidence for compression of morbidity, but obviously more work needs to be done to continue unpacking what this really means. So a more recent project that I've been working on with my colleagues at UC Davis and some of our postdocs in our lab, we're using 8 independent studies to look at the associations between Big 5 traits and dementia risk. So here are preliminary findings. This is the piece that is hopefully going to be under review soon. We found evidence that's really consistent with prior work and also really cleanly showing replicating evidence that high conscientiousness, to a somewhat lesser extent high openness, are associated with lower dementia risk, while neuroticism is associated with higher dementia risk. So this is supportive of this idea of the pathoplasticity of personality, such that personality may be a protective factor against neuropathology, but only as observed via the clinical dementia diagnosis. So put differently, personality isn't necessarily related to neuropathology itself, but it is related to the clinical manifestations, which when we talk about optimizing function in older adulthood, that is almost what we care about the most. So then the last piece I want to talk about goes beyond these clinical observations of cognitive aging and then links us directly to those neuropathological indicators that often underlies cognitive dysfunction. So the correlation matrix you see here on your left is the beginning of some work that my team and I are doing to explore the complex links between personality traits, chronic inflammation, socioeconomic factors, neuropathology, and cognitive function. So the correlations I have here are from a single data set. I believe it's from the religious order study. And we'll extend this work to include other studies that have that postmortem autopsy data. But those studies, like I mentioned before, are few and far between. So doing a full-scale coordinated analysis is pretty tricky to come by. You really have to wait for a lot of people to die also, which, you know, you don't want people to die, but, you know, as a researcher who needs autopsy data, is what it is. So the evidence here that I'm presenting, this forest plot on your right is just, it's actually not a true forest plot. It's showing traits and well-being and how they're related to just one neuropath indicator, TDP43. And we find really consistent evidence that personality is not related to neuropathology. So that is just in and of itself empirically interesting to me, because personality is so consistently linked to so many observed cognitive outcomes, but it's not related to like the accumulation of the neuropath that like drags down our cognition in older adulthood. So what does this mean? So it suggests the possibility that personality doesn't necessarily predispose us to that direct brain maintenance, but it's related to resilience via possibly this pathoplastic model. So to back up just a little bit, in spite of all the evidence for these average patterns of cognitive decline in older adulthood and all the individual differences that come along with that, that's what we're studying when we look at personality. There's also this observation in the field that there exist individuals who maintain high levels of cognitive function in spite of the accumulation of substantial neuropathology. And conversely, there are people who decline starkly during their lives, yet have relatively little neuropathic burden upon autopsy. So we use what we call the residualized approach. This is just the statistical modeling approach that we use to study cognitive resilience, where cognitive function was on the left side of the equation, regressed onto all of our neuropath indicators, of which the Rush RODC has many. And then we extracted the residual. So that residual is an indication of how much of your cognitive function is not being accounted for by neuropathology. So a higher score indicates better function than expected, given the amount of neuropathology. Oh no. And lower scores indicate worse function than expected. So cognitive resilience on the one side, vulnerability on the other. So we found that high neuroticism was associated with lower resilience, and conscientiousness was associated with higher resilience. So here's just a brief summary of the key findings that we have, but in the interest of time, I'm going to move forward. In addition to continuing to unpack the underlying mechanisms of why, in particular, these three traits are so consistently related with all of these outcomes, we also need to continue diversifying the samples we use. As I mentioned earlier, I was priming you for that. Even though most of the work I do is these large-scale replications, so we have really robust evidence, we believe it's fairly generalizable. We're limited by the composition of the studies that we have access to. So using what we have, moving forward, we'll focus on diversifying the nature of our questions and our analyses. So for example, we'll continue examining how socioeconomic status influences these various pathways. We have preliminary evidence that individuals from lower SES backgrounds have worse overall function, lower resilience to neuropath accumulation. So this suggests possible support for cumulative disadvantage theory or maybe resource substitution theory. So we're going to test those competing hypotheses, continue on unpacking how these pathways unfold over the lifespan in the hopes of identifying earlier in life who's at risk for poor cognitive health than in later adulthood. So thank you very much for listening. Hope I didn't go too far.
I feel bad. I'm the bad guy. Silly me closed that folder before when I needed. Let's do this. Oh, I won't do the PDF actually. I'll do the PowerPoint since we already have that open. Sorry, forgive me. I'm clicking here, trying to do things too quickly. There it is. just change to just able to just click forward like before.
All right, hello everybody, buenos dias. My name is Miguel Arce Renteria. I'm an assistant professor in neuropsychology at Columbia University Medical Center. I want to say this is my first time here at this conference, and I want to say thank you so much for inviting me. It's an honor to be here. So it's an honor to meet a lot of you. It's a great room with awesome scientists, a lot of them Latino, a lot of you all Latinos, which is very inspiring. So thank you very much for the invitation. I'm excited to share some of my work. And so I'll be talking about bilingualism specifically. So right, deconstructing bilingualism, a little bit about AD biomarkers and brain reserve. Some of the disclosures that I always like to begin with is that I do want to say that I am bilingual. Right? Soy bilingual. Como dijo Silvia, I'm from Tijuana, Mexico. So obviously the talk is about how bilingualism may be protective. So obviously I would love that to be true. But I will remain objective and I let the data try to speak for itself. I'd like to disclose that. Obviously, some of my funding sources, I'm funded through the NIA with the K99R00 and through the Alzheimer Association. I forgot to mention, I'm also funded through the Columbia RICMAR as well. And I do like to plug as well. So I'm also the co-chair for the Bilingualism, Literacy, and Language Special Interest Group of the Alzheimer's Association, the ISTART group. We've been meeting since October 2020. We usually take summers off when we meet once a month. We're going to meet once every 2 months now. And if you're interested in discussing bilingualism, language literacy with a great group of multidisciplinary scientists from all over the world, you just have to be a member of ISTART. But I'd be happy to chat with you more about if you'd like to join these meetings. So, right, to begin with is that there's a lot of studies, right, that suggest that bilinguals may be able to retain similar levels of cognitive functioning in the face of age and or AD-related neurodegeneration compared to monolinguals. Meaning that several studies have found that bilinguals, if they will develop dementia, they will develop it much later in life compared to monolingual groups. We also find evidence for what we call the bilingual cognitive advantage, where bilinguals outperform monolinguals across different cognitive domains, largely executive functioning, language, attention, and some episodic memory as well. So there's several studies to find this kind of support. However, there's a bunch of other studies that do not, right, that don't really find any benefit on bilingualism in reducing the risk of cognitive impairment or reducing the risk of developing Alzheimer's disease dementia as well. There are a lot of methodological design differences between these studies. So some of the ones that find a benefit are largely retrospective and clinic-based. Those that do not find a benefit are prospective and largely community-based. I like to focus on other methodological issues that I'll be working through my work. So I'm going to try to walk us through a conceptual framework that I like to use in my approach of how do we understand, how do we truly evaluate whether bilingualism confers or not a benefit, a cognitive reserve. So there's a lot of methodological factors that can complicate that work. And so first, I'll try to walk us through this, right? So the idea, right, was we have bilingualism, right? You have aging, right? And things happen to the brain, and then it leads to the outcome that we're interested in studying, right? Dementia, cognitive decline, cognitive impairment, right? And so that's a whole lifetime. And bilingualism happens somewhere in the life. And so to evaluate whether bilingualism confers reserve, you really want to evaluate one of these two pathways. The first one on the right is evaluating more of a cognitive reserve, whether the bilingualism modifies the association of brain and brain health on your outcome of interest, cognition, meaning that it's weakening. That as we saw from the previous talk about if we have greater pathology on the brain, you would want to see that you're able to maintain cognitive functioning. So some studies would evaluate whether bilingualism modifies that association. On the brain reserve side, you could study whether bilingualism modifies the association of aging on brain health, because as we get older, we get cortical thinning, and so does bilingualism protect that? So we can evaluate that. But in addition to that, right, bilingualism doesn't happen in a vacuum, right? So there's a lot of childhood contextual factors, adult contextual factors, migration history that are confounded with the ability or the opportunity for someone to become bilingual, right? Because people don't just randomly become bilingual. There's a lot of life force factors that we need to keep in account, especially because some of these same contextual factors are also associated with our outcome of interest, right? Such as brain health and late life cognitive health. And so the last thing I like to also mention is also, what is bilingualism? What about bilingualism can potentially provide a benefit? Most studies really, either there's no consistent way to define bilingualism, and they really just treat bilinguals as a monolithic group. So just comparing bilingual against monolinguals. And if several of you here are bilinguals, you'll know that it's more complicated than that, right? It's important to understand, well, how old were you when you acquired the second language? How proficient are you in the language across different modalities, writing, speaking, understanding, reading, and how much are you using the language, right? Because if we're thinking of it, for instance, like with the literature on exercise, right? That, exercise can be beneficial for health. It's not whether just you did it or not, right? It's, well, how much is it? What type of exercise is it and for how long? And so we really need to start to deconstruct bilingualism to look at these different aspects and how they may relate to the outcomes of interest. So for my talk today, I'll be providing some evidence evaluating whether of more of a brain reserve side, whether bilingualism modifies cross-sectionally the association of age on brain status, looking at cortical signature, cortical thickness, while trying to account for several of these contextual factors and deconstructing bilingualism into these three different components. So my aims and hypotheses, I hypothesize that bilinguals will have better cognitive functioning compared to monolinguals, but then within bilinguals, better cognitive functioning will associated with active bilingualism, here defined as using two languages every day. This is going to be through self-report, again, to more detail, compared to bilinguals who only use their second language every once in a while. It'll be associated with higher L2 proficiency and with an earlier age of acquisition. And then lastly, whether bilingualism buffers the effect of age and cortical thickness. Specifically, I'll be looking at the 80 cortical signature regions. These are 9 cortical regions that are associated with greater thinning over time, are associated with an increased risk of developing dementia. So I'll be focusing on a composite of these regions. For this, I'm using the study from, participants come from the Offspring study of racial and ethnic disparities in Alzheimer's disease. It's a community-based study of dementia and of the social determinants and genetic risk of dementia in the Washington Heights, Inwood, Columbia area of New York City. We'll be using participants who self-identify as Latino or Latinx, who are, for the study, they're 30 or above. To try to account for the differences between the lived experiences of being an immigrant or not an immigrant, how you learn the language, we'll be focusing only among those who were born outside of the United States, who completed a language history questionnaire for where we're able to define whether they're bilingual, whether they learned another language or not. And then from there, whether they use both languages daily to define active bilingualism, getting an average self-reported proficiency across speaking, reading, writing, and understanding, and then also self-reported the age that they start to learn their second language. In this case, given that all the participants are Latino, they're all immigrant, their second language is English. All of them, their first language will be Spanish. All the participants completed a comprehensive cognitive assessment where we evaluated the domains of episodic memory, attention and working memory, executive functioning, processing speed and language abilities, using several different measures from like the NAC and as well as the toolbox. And lastly, a subsample participants completed a neuroimaging visit from where cortical thickness is derived from T1 scans using Free Surfer. And as I said, an 80 signature average of the 9 cortical regions. So here, working with a sample of 521 participants, here grouped between bilingual and monolingual. Here just describing the differences between the two groups. They largely differed in terms of age. The bilingual group tended to be a little bit younger than the monolingual group. They were both about mostly women in both groups. In terms of education, there was a slight difference where bilinguals had a little higher education compared to the monolingual group. Here we're using parent years of education as a proxy for childhood socioeconomic status. And there's also differences, but it's about the same. The bilinguals, their parents had a little bit of a higher years of education compared to the monolingual group. Given the area that we're working with, I am Mexican, but the group that we're working there are primarily Dominican. It's a Caribbean enclave there. And as you see, the majority are Dominican, but from both groups. Both participants can be tested in Spanish or English. As you would imagine, the monolingual group here, all of them were tested in Spanish, and within the bilingual immigrant Latino group, the majority were tested in Spanish, but some participants chose to be tested in English. And now then within the bilingual group, I think some characteristics to mention is, as I said, so for the bilinguals, most of them, their first language was Spanish. Those that didn't say that was their first language, it's because they said both English and Spanish was their first language. They were primarily Spanish dominant, meaning that that was the language they would prefer to use more regularly. In terms of how much they're using in a daily basis, about 60, a little more than half said that they use both English and Spanish. And their English proficiency was rated as a 5. It's a 7-point scale. 5 means good. And at pretty late age of acquisition, which is interesting. Say they all on average said that they learned their second language when they were 17. In the bilingualism literature, outside of like cognitive aging, early is usually before 7 years of age. So this is pretty late. Okay, so now for some of the results, what I'm showing here is the estimates and the confidence intervals of the differences between bilingual and monolingual, accounting for the covariates below. It's just for differences between these big two groups. Here you'll see that bilinguals are performing better than monolinguals on measures of simple auditory attention, semantic fluency, letter fluency, visual working memory, and set shifting, so several domains. But now when we then look within the bilingual group to try to understand what aspects of bilinguals may be driving that, you'll see here we have active bilingualism on the left. Using 2 languages daily was only associated with better performance on processing speed. Greater L2 proficiency was associated with better working memory, semantic fluency, letter fluency, language abilities. And then a later age of acquisition was associated with worse semantic fluency and worse letter fluency. So finding some evidence that these different aspects of bilingualism may be associated with different cognitive abilities. And just for the last a bit of work mentioning the cortical thickness. This is a cross-sectional association, which here on the Y we have the composite for cortical thickness, and on the X-axis we have age. We have bilinguals in the blue group and blue line, and monolingual in the green. We had a significant interaction between bilingual status and age and cortical thickness. Largely a simple slope discomposition indicates it was driven by the right side of the figure, indicating here that monolinguals at later ages had lower cortical thickness compared to the bilingual group. So this would be suggestive of either a brain reserve or brain maintenance. But again, this is not the most convincing results. It's also cross-sectional. We need to look at this over time. But then when we look within the bilingual group, again, seeing if these aspects are related to any of these, and it's not. So neither being active or proficient, more proficient, or earlier age of acquisition, we're associated with different, we're not associated with different relationships between age and cortical thickness. And so just to conclude, so bilingualism was associated with better cognitive functioning across several domains, largely more in the language and executive functioning aspects. Active bilingualism, proficiency, and earlier age of acquisition were associated with better cognition, but we do see it, we get more bang for our buck with proficiency. It seems to be the case. And that bilingualism may, emphasis with the may, protect against age-related structural declines in AD cortical signature regions. However, we still really need to now understand the joint relationship of all these different aspects of bilingualism to the cognitive outcomes, both cross-sectionally and over time. We need to include as well objective assessments of bilingualism, given that all of this is self-report. And so we are also right now collecting objective assessment of proficiency. And as well, we need to generalize this work to other bilingual populations. So for instance, I'm excited, I'm working with the MPAS team to collect some of this data, hopefully in Mexico as well, to start to look at this in different populations, both within the US and outside. And right now I was just looking at cortical thickness, but we need to look at also more traditional biomarkers of Alzheimer's disease, such as, more looking at the neuropathology like amyloid and tau. So I'd like to acknowledge all my colleagues and collaborators, and obviously the staff and the participants. And that's a photo of everybody in the lab, and my Twitter, if you have questions, want to message there or anything. Cool, muchas gracias.
Sorry, just give me 1 second. you just need to press that to go forward and that one to go back. So right to go forward and left to go back. Sorry.
So what are your stop times on
Uh,
your time thing?
5 minutes left, 1 minute left.
Okay.
So 15 minutes, sorry. I'll try not to terrify you. So I'll just move that out of the way.
Well, it's a pleasure to be here once again. And I think the last time I gave a talk for our group here was about 11 years ago in Austin. So it's been a while. So, but it's a pleasure to be back again. I just wanted to begin by saying that I think that one of the most critical things that has happened in the whole world of cognition, of course, is the enormous exuberance that we have had in funding research associated with anything having to do with aging, but specifically with the brain. And there's been tremendous opportunities, as you all know, and I think this is a golden opportunity time. And I want to speak to that golden opportunity a little bit in the way I go about this, because I'm going to focus on the question of what has happened from the standpoint of understanding cognition as a phenomenon, both as a phenomenon that affects the normal process of aging as we get older, what really goes on, and is there really a normal aging, or is there really something that we can't call it quite that, because we know, frankly, it's hard to characterize what it is, because we have very different approaches to it. We have different measurement approaches in terms of what we've actually considered to be a serious marker of deterioration, for example, and what is disease. So it's a question of what is normal and what isn't normal from the standpoint of disease versus non-disease from the standpoint of Alzheimer's. Now, I'll get into that now and have to push through it. This used to be a 1-hour presentation, so it's going to be a little shorter now. So, but I've cut it back. Okay. So the goals, and I just want to say, first off, I have been an advocate for more money for research in the Congress of the United States, representing us against Alzheimer's, and also I've done work for Alzheimer's Association and technical groups. So I've been there, and believe it or not, they want to fund it. Both Republicans and Democrats want to fund more and more, and we're up to $3.2 billion for aging research now. So I think that's wonderful. So my point here is to primarily look at the question of, how is cognition, let me go back one here, of understanding the Alzheimer's disease and why developing a cure to reach the disadvantage is going to be an arduous journey. And distinguishing health and cognitive aging and unhealthy cognitive dysfunction leading to dementia, and understanding why a life course approach is important, and understanding just a little tiny piece of the management problem, especially without a cure. So as we move forward in this, it's really a history lesson of the last 7 years and the excitement that's taken place in the history of science in the world of cognitive understanding, and what that opportunity presents for you. Now, what is cognition? Cognition refers to mental functions involved in attention, thinking, understanding, learning, remembering, solving problems, making decisions. Obviously, it's a gradual ongoing process. It's highly variable. And you can see that as people get older, they have very different phases that they go through and different capabilities that they retain and that they lose. So I understand the notion of cognitive health, but it's hard to understand normal, because from the standpoint of aging, we're all born with different cognition. We all follow through life with different cognition. We have a whole series of experiences in the environment and social experiences that changes all of that. So it's very difficult, really, from the standpoint, not just research, but you can imagine what clinicians are up against when they're trying to understand what they're looking at, and say, oh, this person has a problem or not a problem, or what level of severity is the problem, unless it's extremely marked. So that's where we've been in the field coming up to this point. Now, we know that any cognition measures we come up with to determine whether people are so-called normal or abnormal really have to do with a lot with the same problems that we face with testing an IQ test and with testing with SATs and anything else, because it is going to be socially based on what we pick out to decide that these brains are not doing well, especially in the absence of clear-cut biomarkers where we know something's going on in the brain that's causing a disease. So we really have to put that unity together, and we haven't had it in the past, and so we're still searching around for the best way to assess and to do it efficiently and to do it in research, et cetera. As you can see, cognition performance it combines knowledge acquisition, performance level, and skills, variously defined literacy, verbal processing, working memory, vocabulary, verbal fluency, world knowledge, word recall, text recall, and actually problem solving, which is a big piece of it, being able to solve common problems of everyday living. So let me just say that to me, this is the core of what I really want to get across to you. If I said nothing else to you today, what has been going on in this arena in the last 7 years of the history of Alzheimer's disease research. Because up until about 7 years ago, we were heavily influenced by the entire genetic influence, I think, of early onset Alzheimer's disease, which affects people really earlier in life, like in their 40s and 50s, usually dead by the time they're 60, because it is a fatal disease. Now, that's a very different thing. It affects about 7 to 8% of the total Alzheimer's group, and the overall group actually has a quite different picture, but we were very influenced by that work because it's autosomal in the sense that if you have the gene, you're going to have the disease and you're going to die from it. Okay, that's early onset Alzheimer's. That carried over to a great extent. And up to about 7 years ago, people were talking about 70% or so of the liability for the disease was really genetic. Now we're down to 7 to 10%. That's quite a change in science, isn't it? I mean, we jumped from 70 down by a factor that's phenomenal. And now we've opened up the field for you, because the field now is saying across the life course up to and including prenatal time, we're talking about factors that are influencing the brain and developing a brain that is robust against depression and against dementia, which I say depression because there is interrelationships between depression and dementia as well. So the bottom line is now we're looking at something that for a long time, we were stuck with a model that basically said it was dominated by one thing. Now we're saying it's dominated perhaps to a certain extent still in the focus of looking at APOE4, which is the primary gene we look at, which itself is related to a whole region of other genes. And we find that even if you have APOE4, you don't necessarily get Alzheimer's disease, and many people get Alzheimer's disease without APOE4. So it's that kind of a variability, and most of the effect is interactive with all of these other numerous risk factors, including the social, environmental, biologic, genetic, physiological factors that we'll be talking about here in the 2 days that we're here. So now we're into a multi-path world coming forward over the entire life course, and which gives us an opportunity to start thinking of, is there a way further up the pathway to start intervening, and what would we do to lower that risk? Now, when we look at the whole question of where we have been stuck for 2 decades trying to find a cure, and that is a cure from the standpoint of something that will stop the disease. We've been stuck in this ATN, which is basically the amyloid tau neurodegenerative framework, right? And this has produced no cure. Okay, we've had a lot of partials that didn't work out, and I don't want to get into the time it takes. I can certainly explain it to you on a personal basis what has happened with that, but we don't have anything right now that looks like a cure or a medication in the field, which means that clinicians have to go back and rely upon psychiatric drugs that were intended for schizophrenia and bipolar and depression, et cetera, and it frankly does not work. So we are in a world in which we now have to back up and say, are there earlier stages, both outside the body and inside the body, and the way disease gets inside the body, where we can now begin to understand mechanisms. It's not just genetic, but mechanisms that in fact link social experience, environmental exposures to toxins and things like this. So and my last point there, to me, the analogy is much more like a river. Each one of us represents our own individual river of experience from the time we were born, going forward across our lifetime, the exposures that we've had. As I indicate here, the risk factors that we experience include things like cognitive reserve, exposure to toxins, diabetes, heart disease, serious mental illnesses. People with serious mental illness have 3 to 4 times the risk of moving on to Alzheimer's disease. Traumatic brain injuries, the dementias, about 30% of all Alzheimer's cases are made up of previous dementias. Vascular dementia especially, but there's a full range. Lewy body, Parkinson's disease, et cetera. So you can see, and then of course, things that happen in later life, emergencies of various kinds of medical emergencies, surgeries, et cetera, traumas, physical traumas, not just psychological traumas, which are also very important. So you can see what I'm talking about here, that this is an opportunity for us to think in an open frame. Now, what kind of interventions will work, but what can be sustained? Who's going to pick it up? And I think that's the critical thing. I mean, we all talk about, well, cognitive reserve, it's not, obviously we have a problem there. We can perhaps do interventions later in life. Who's going to do those interventions? Who's going to sustain those interventions? We need to start talking about interventions in this group. We need to there's no way to get better knowledge about the disease and stopping the precursors than doing interventions. And I know it's a lot of work. I've done them. I've done interventions a lot of my career, and it's hard to do, but it's very, very important. So Alzheimer's disease is fatal. It affects 40 to 50% of 80 cases, which could have been prevented. Actually, in Mexico, they say it's really higher because they have more risk factors, probably 50, I think 56% is what I hear in Mexico when I've gone there, because there's so much obesity and of course, cognitive reserve and a lot of other poverty-related issues and stress issues. And the as I've just mentioned, underlying biology is not well understood. Now, I wanted to show you this because this is very interesting. It gives you a different way of understanding what happens to cognition over time. This is a panel study taken from the Health and Retirement Survey from 60 to 90 years of age. And what this shows you is that orange line that goes through there is the trend line for the entire sample, okay? The upper one is for those who are above that trend line, so you can see the decay in cognition over time is gentle. It really doesn't go down seriously until about 80 years of age. And then you see the bottom trend line, which goes down precipitously, and it starts at quite a different point as well. So already by 60, you can see a vast difference in groups, and you can see that there's a serious decay in cognitive performance after the age of 80, going all the way on. And that's just about what we see with every measure that we use. 80 is a critical point for every organ in the body. I'm about to be 80, so I know about that. So anyway, here you can see a marker, which is memory, which of course is much more to Alzheimer's disease and dementia than just than memory, but this is memory and serious impairment with memory. And you can see at the bottom here, this is color-coded. It's not pink for women, but it's orange. So we have blue and orange. You can see the very low levels at the bottom in bold are the levels of serious memory impairment 65 to 69. And you can see how it starts jumping up. And by 85 and over, it's a third. It's a third of just about a third of both groups have serious memory impairment by that point. Now, what this is all about really is the fact that memory, as I indicated, is one serious marker, but in Alzheimer's disease, you actually had a higher rate for women than men because most of the men have already died. The attrition to mortality has taken them out of it. So you actually get a shift here where you get about 60% of the cases would be among women over 80 years of age. Okay, so that's what happens there. And this is basically what you've probably seen this before. I hope you've seen this before. This gives you a picture of what is happening. And this is, of course, a relative issue because what we're talking about is different populations with different risk factors are obviously going to have normatively earlier or later starts in the neurodegenerative process. The neurodegenerative process is approximately a 15 to 20 year phenomenon for most groups. Some people can go on and on. I mean, I've seen cases where in the Mexican population where people can go on with dementia for a long, long time, but it's very rare. Most of it fits into this picture. So this is normative. So what you're really seeing is you really have the earliest stages of the disease beginning. This is the loss of neurons in the brain with neurodegenerative disease beginning in about the age of around 60, okay? And normally what we see is a preclinical stage of 12 to 15 years. Then we see MCI, and then with MCI being diagnosed, which of course is not diagnosed for everybody, but I'm saying if it is diagnosed, what you normally see is within 3 to 5 years, you're going to see Alzheimer's or the dementia diagnosed. And of course, people usually live depending on how early they were diagnosed. In California, with Latinos, we find that after diagnosis, they only live about 3 years because it's late diagnosis. So it really depends on, and other studies show 5 years, 7 years, depending on their good fortune or bad fortune. I don't know, because it depends upon finding out, and you're not necessarily able to do anything about it. So I think that really gives you, I think, the clinical picture. And you can see the problem here that we have and the great challenge, because we are going to be struggling to come up with a medication to work with this, but how will it work if the neurons have already been lost? And really the difference between what we would call dementia in the Alzheimer's context is that between that and non-dementia and non-Alzheimer's disease is the loss of neurons in the brain. That's a physiological difference in the brain of these concentrations, the loss of neurons until you hit a level of dysfunction. It's really serious. And for most people, literally 2/3 of the, well, probably about, let's say 60% of the population, they will not experience that serious decline to that point. But we're talking an enormous number of people who will. And this is going to be an increasing problem, obviously, with aging in the population. And I just put this up because you got to realize that for our population, they're the last ones that are going to get any cure. They're the last ones that are going to get into care. And these are the reasons why. Disease understanding, this is how far we are away from it. Disease understanding, preclinical development, clinical trials and biomarkers have to be developed, which we do not have as yet. We have a few. In Australia, they give older people, they take samples of their cerebral spinal fluid, and they can find it that way because they can find the amyloid in there that way, and they can actually do very solid prediction. We can't do that here because people are so afraid of doing that, right? Spinal taps, you know, it's kind of like, that was a movie. Then you have the need for regulatory and access issues. You know, the FDA had that one drug from Biogen, and they said, do another study. So that's another 5 years down the road. So at least 5 years. The big data and precision medicine, because there's variety across all these populations. You can look at the Indian population in Mexico. You look at APOE4, it's distributed completely differently into different groups. And its value, and we don't even know what its predictive value is for the disease. I mean, these are issues that we have to decide with higher technology. And the last point is, you know, the whole question of market readiness. Who's going to deliver the therapies? Primary care physicians, or are you going to look for a neurologist? So you can see those are all issues that point to the fact that we need to do something to prevent this as a public health issue. And all the things you're going to see presented at this, this conference, potentially those are areas for intervention. And if nobody does the interventions, we're going to have those outcomes. I'll stop there.
Yep, so the last presenter we have is Melissa, and I have her video, so I'll just bring this up so that we can